You're staring at a complex topic. Maybe it's machine learning, financial modeling, or advanced statistics, and your brain just freezes. It feels like trying to drink from a fire hose. Richard Feynman felt this way too when he first encountered quantum electrodynamics. But he developed a mental framework that turned overwhelming complexity into manageable simplicity. And once you understand his method, no subject will ever feel too difficult again. Here's the brutal reality. The ability to learn complex subjects quickly is now the most valuable career skill you can have. Technology changes every 6 months. Business models evolve constantly. The skills that got you hired are obsolete within 3 years. If you can't rapidly master new, complex domains, you're going to fall behind, permanently. Your colleagues, who can learn fast, will get the promotions, the opportunities, the options. You'll be stuck doing what you already know while the world moves past you. This isn't about being smart. PhDs struggle with new subjects just like everyone else. This is about having a system for breaking down complexity. Without that system, every new field feels impossible. With it, you can master anything. Hooks, 45 seconds. When Feynman joined the Manhattan Project, he was the youngest physicist. There, surrounded by legends like Oppenheimer and Fermi, they'd spent decades on nuclear physics. Feynman had spent 2 years. He was completely overwhelmed. The equations looked like hieroglyphics. The concepts seemed impossible. But instead of giving up or pretending to understand, he did something different. He broke every complex concept down to its fundamental parts, then rebuilt it in his own mind. 6 months later, he was solving problems that had stumped senior physicists for years. The difference wasn't intelligence, it was his deconstruction method. Main content, 8.5 minutes. Let me show you exactly how Feynman turned overwhelming complexity into crystal clarity. The fundamental principle, complexity, is just simple. Things combined. Nothing is actually complex. That sounds absurd, but it's true. Complex just means many simple things working together. A car engine seems complex, but it's just controlled explosions pushing pistons, which turn a crankshaft, which turns wheels. Each individual step is simple. The combination creates complexity. Quantum mechanics seems complex, but it's just particles behaving like waves, which means their position is probabilistic, which means we describe them with wave equations. Each individual step is conceptually simple. The combination creates apparent complexity. Feynman's first rule: never accept something as just complex. Always assume it's actually simple things you haven't separated yet. Step 1. Identify the core question. When facing a complex subject, most people try to understand everything at once. Feynman did the opposite. He'd identify one core question that, if answered, would unlock everything else. For example, when learning quantum electrodynamics, QED, the field seemed impossibly complex. Hundreds of equations, dozens of theorems. Years of prior knowledge required. Feynman asked one question: how do electrons and photons actually interact? That's it. Not, how does all of QED work? Just, how do these two particles interact? By focusing on this one question, he had a clear target. Every piece of information either helped answer this question, useful, or didn't. Ignore for now. This ruthless focus prevented overwhelm. Instead of trying to learn an entire field, he was just answering one specific question. You can do this with any subject. Learning economics? Don't try to understand economics. Ask, what determines the price of something? Learning programming? Ask, how does a computer follow instructions? Learning finance? Ask, how is risk calculated? One question. Get obsessed with answering it. Step 2. Break down to first principles. This is Feynman's most famous technique. First principles thinking means breaking a concept down to the most fundamental truths, the things that are true by definition. then building up from there. Let me give you a real example. Feynman was trying to understand how a radio works. The standard explanation was, electromagnetic waves carry information through amplitude or frequency modulation, which is decoded by a heterodyne receiver circuit. That's complex jargon. It explains nothing. Feynman broke it down to first principles. First principle, energy can make electrons move. Second principle, moving electrons create electromagnetic fields. Third principle, those fields can make electrons move in other objects far away. From just these three simple truths, he rebuilt his understanding. A radio station moves electrons in an antenna using electricity from a wall. That creates an electromagnetic field that spreads out. That field makes electrons in my radio antenna move in the same pattern. My radio detects that movement and turns it back into sound. Same concept. Zero jargon, built from simple truths. Here's how you do this. Take the complex concept. Ask, what would have to be true for this to work? Keep asking why until you hit something obviously true. That's your first principle. Then build back up using only logic and those fundamental truths. Step 3. Create your own examples. When Feynman encountered a new concept, he never relied on the textbook's examples. He'd immediately create his own. Why? Because creating an example forces you to truly understand the concept. You can memorize someone else's example without understanding anything. You cannot create your own example without understanding. Real example. Feynman was learning about enzymes in biology. The textbook said, enzymes are biological catalysts that lower activation energy. He created his own example. An enzyme is like a specialized tool that makes a hard job easier. Breaking a stick with your hands is hard, but if you have a vice grip holding the stick, you can break it easily. The vice grip didn't add energy. It just made it easier to apply your energy effectively. That's what enzymes do for chemical reactions. This example was nowhere in the textbook, but by creating it, he proved to himself that he understood the core concept. Your examples don't have to be perfect. They just have to be yours. The act of creating them builds understanding. Step 4. Explain it to someone who knows nothing. This is the Feynman technique you might have heard of, but most people apply it wrong. They try to explain to someone who already has background knowledge. That's not enough. Feynman would explain concepts to people who had zero background, not physics students, janitors, secretaries, his children. Why? Because they'd ask questions that revealed hidden complexity. Wait, what's an electron? How can something be a particle and a wave? Why does that matter? These stupid questions forced Feynman to examine assumptions he didn't even know he was making. They revealed gaps in his understanding that weren't visible when explaining to experts. Try this. After learning something, explain it to someone outside your field. When they say, I don't get it, that's gold. That's where your understanding is still shaky. If you can't find someone, write it in simple language as if explaining to a smart 10-year-old. If you use any jargon, define it in plain English. If you can't define it in plain English, you don't understand it yet. Step 5. Find patterns across domains. This is Feynman's secret weapon for handling complexity. He'd look for patterns he'd seen in other fields. When learning biology, he noticed that cell membranes selecting what to let through was similar to Maxwell's demon in physics, a theoretical entity that sorts particles by energy. The pattern was the same, selective filtering based on properties. This cross-domain pattern recognition did two things. First, it made new concepts familiar. Instead of biology being completely foreign, it was just physics patterns applied to living things. Second, it revealed deeper understanding. If the pattern exists in multiple domains, it's probably fundamental. Understanding it deeply in one domain gave him a head start in others. You can do this too. When learning something new, ask, what does this remind me of? The analogy doesn't have to be perfect. You're training your brain to find structural similarities across different content. Step 6. Teach it back to yourself. Feynman had a habit that seemed crazy. After learning something, he'd write a lecture to himself explaining it from scratch, not notes, not a summary. A full lecture with introduction, examples, and conclusion, written as if he were teaching a class. This forced complete organization of ideas. You can't lecture on something you halfway understand. Every gap becomes obvious. He'd write these lectures at night, then read them the next morning. Often he'd find sections that didn't make sense even to himself. Those were areas where he'd fooled himself into thinking he understood. You don't need to write a full lecture, but try this. After learning a concept, write 3 paragraphs explaining it. Opening paragraph, what it is. Middle paragraph, how it works. Final paragraph, why it matters. If you can write those 3 paragraphs clearly, you understand it. If you can't, you found your gap. Step 7. Accept temporary confusion. Here's what separates Feynman from most learners. He was comfortable being confused. Most people hit confusion and panic. I don't get this. Maybe I'm not smart enough. Maybe I should give up. Feynman hit confusion and thought, great, I found the edge of my understanding. Now I know exactly what to focus on. Confusion isn't failure. It's data. It tells you precisely where to direct your effort. When you feel overwhelmed by a complex topic, ask, what specifically confuses me? Not all of it. What exact part? Usually you'll find 1 or 2 specific concepts that, if clarified, would unlock everything else. Focus all your energy there. Ignore everything else until those concepts are clear. Feynman would spend days on a single confusing concept, not trying to understand the whole field, just that one thing. Once it clicked, everything else fell into place. A real example. Feynman learns biology. In the 1960s, Feynman decided to learn molecular biology from scratch. He had no background. The field was completely foreign. Standard approach would be read a textbook, memorize terms, move through chapters sequentially. Feynman's approach. Asked one question, how do cells copy DNA? He broke it down to first principles. DNA is a molecule. Molecules have shapes. Shapes determine what they can connect to. He created his own example. DNA is like a zipper. Each tooth on one side matches a specific tooth on the other side. To copy it, you unzip it, then build 2 new matching sides. He explained it to his sister, not a scientist. Imagine you have a recipe written in a special code. The cell needs to copy this recipe perfectly. It does it by splitting the recipe down the middle, then using each half as a template to rebuild the missing half. He found patterns. DNA copying was just like crystal formation in physics, pattern replication based on molecular complementarity. Within 6 months, he was attending biology conferences and asking questions that stumped PhD biologists. Not because he memorized more, because he understood more deeply. Your action plan. Pick one complex topic you've been avoiding. Start tomorrow with these steps. Write down one core question about it. Break it to first principles. What must be fundamentally true? 3. Create your own simple example. Explain it to someone who knows nothing about it. 5. Find one pattern from something you already know. Write 3 paragraphs teaching it to yourself. Identify the one specific part that still confuses you. Do this for any complex subject. The feeling of overwhelm will disappear because you'll have a system for dismantling complexity. Feynman's greatest insight wasn't about physics, it was about learning itself. He realized that complexity is an illusion created by poor explanation and lack of structure. Any subject, no matter how advanced, can be broken down into simple components. The barrier isn't the subject's difficulty, It's your lack of a deconstruction system. Once you have that system, nothing is too complex. Everything becomes accessible. The genius-level topics you thought were beyond you are just simple truths you haven't separated yet. And now you have the exact system Feynman used to make the impossible routine. Right now, pick the complex topic that's been intimidating you. Write down your one core question about it. That's your starting point. Use Feynman's deconstruction method and watch the complexity dissolve. Write your question in the comments below. Subscribe for more systems that turn complex into simple. Remember, nothing is actually complex. It's just simple things you haven't separated yet.